Today we'll look at length and midpoint of a line segment and parallel and perpendicular lines. So we'll start with midpoint. So what are the coordinates of the midpoint of the following line? This line here is called a line segment. Let's call this point A and call this point B. So if we wanted to get the midpoint of the line segment AB, I'm talking about the coordinates that are in the middle of this line segment here. And hopefully you can see that it's going to be, the midpoint is going to be 0, 0. You can do that by sight. Note that the x values, -5 and 5, and the y values, -5 and 5, are, well, just note. Okay, what about this line here? So x values are -5 and 5, and our y values are -4 and 6. This function is the same as this one, except it's up 1 unit. So the midpoint is going to be here. So I believe by sight that the midpoint is going to be when x is 0, y is 1. Now, an interesting thing to note, that these y values here, the middle, what's the middle of -4 and 6? Okay, because that's what really we're after here is I want this value here, the value that's in the middle of those 2 points. And the way to find out what's in the middle is to average them. -4 plus 6 on 2 equals 2 over 2, which equals 1. Okay, so the midpoint of the y values will be at y equals 1. And the midpoint of the x values, you note, is going to be -5 plus 5, which is 0. And 0 divided by 2 is equal to 0. So it's going to be at 0. Right? And you connect up those two and you've got your midpoint of your function. So the way we calculate the coordinates for any line, that is the x and the y values, is we simply, to get the midpoint, we average the x values and we average the y values. And note that when we put that together more formally, what we get is the midpoint. The x value and the y value goes here. So we stick together the x values and we divide by 2, stick together the y values and we divide by 2, and that gives us our ordered pair. Right, so here's an example. Find the line segment joining the points 1, 2 and another point x, y is bisected or cut in half by that, i.e. this is the midpoint. So the midpoint is 3, 6. Right, find x and y. So let's try this graphically and then we'll try it using the formula. So we've got 1, 2 is there. The midpoint is 3, 6. And there's another point x, y down here. All right. So you can see here, if we just basically continue the pattern of going 2 across and 4 up, 2 across and 4 up, we're going to get at 5 and 10. So the midpoint, not the midpoint rather, this other point here will be 5, 10. That's what I believe. All right. Now I'm going to get some algebra happening here to pump out the value, or the values rather, of this other point here and check whether it does come out as 5, 10. It should. Right, so recall that the midpoint is found by doing x1 plus x2 on 2, and it gives us the value of the x, or the x value of the midpoint. So the answer is going to be 3 equals x1, I've got that, that's going to be, let's call that 1, plus x2 over 2. Right, let's solve for x2. 2 multiplied by 3 is 6 equals 1 plus x2. We'll subtract 1 of both sides. x2 is equal to 5. So that's suggesting that if I draw the this up as an ordered pair, the x value would be 5. And that is what I did graphically. All right, let's do the y value. So it's going to be 6 is equal to 2 plus y over 2. 2 6s are 12. Subtract 2 from both sides, that's 10. So it should be 5, 10, which is what I got, again, graphically. So that's a good sign. Also now, you could calculate the midpoint of 1, 2 and 5, 10. And what should happen is you get this value here, 3, 6, this coordinate here. All right, what about if you're finding distance between points? So this one here calculates the midpoint, okay? And now we're on to distance. That is, we've got a line segment that's joined by these 2 points here. So I'll call this point A and point B. So line segment AB, we want to work out how far along the line is this. All right. So the technique will be to use something that you already know, which is Pythagoras' theorem. Okay, so what we're going to do is note that the x value here is 1 and the x value here is 3. And that means that this line here is 4 take away 1 is 3 units long. This line here is going to be 3 and -1, which means it's 4 units long. All right, now you might know this already, that the hypotenuse, or that line segment, is going to be 5 units long, but you might need to use Pythagoras' theorem to find that out. So let's go c squared equals a squared plus b squared. And what we'll do is we'll go c squared equals 3 squared plus 4 squared. C squared is equal to 9 plus 16. C squared equals 25. What we'll do is we'll root both sides. So root this side and root this side. C equals plus or minus 5. But in this case here, we've got a distance between 2 points. So we're going to say, but C, the distance, is greater than 0. It's got to be a number greater than 0. So C is equal to 5. Now, you might wonder why we took the plus or minus there, and that's because when we started with c squared equals 25, what we were looking for when we solved this is the numbers that make this true, and both positive 5 and negative 5 when squared equals 25. So there's 2 solutions to this problem. But then what I did was removed one of the solutions because you can't get a negative distance. This harks or emphasizes this point here, x squared equals 9. So be careful when comparing this to the following question. Solve x squared equals 9. Well, I think we did do the right thing in those notes. Okay, so we're just going to solve this one here. So forget this statement here. Let's just solve x squared equals 9. So the solution is when I root both sides that I get x equals plus or minus 3. Okay, there's 2 possible solutions here, is plus or minus 3. Now, of note though, what is the square root of 4? Some students, when they see this, do what I call falling in love with the plus or minus and say that the square root of 4 is plus or minus 2. No, it isn't. The square root of 4 is exactly what we did when we were in year 7, which is that's going to be 2. And the way we work out whether we need the negative or positive root is we tell you whether we want the negative root by simply putting a negative sign out the front of the root. This means root 4 for me, please, and then negate the result. So this answer here is negative 2. Generally, the distance between 2 points can be found by using the formula, this one here, D equals, okay? And it looks long and it looks complicated, but really all it is a glorified version of Pythagoras' theorem and nothing else, okay? C squared equals A squared plus B squared. What they then have done is this A value here and this B value here is worked out by working out the difference between the X values and the difference between the Y values and squaring them, okay? That's exactly what we did over here. We worked out the distance between the X values and the distance between the Y values. And we do that by subtracting 3, subtract -1 is 4, and 4 take away 1 is 3. All right, and so what they've done basically is then gone C equals, they've rooted both sides and acknowledged that a distance is always going to be positive. So this plus sign here is always going to be positive, A squared plus B squared. And then they've replaced A and B and C with distance equals the positive of, the way we get the A distance is we subtract the X values and square them, and we subtract the Y values, Y1 squared. All right, so all that is Pythagoras' theorem, nothing else. To find the distance between the points 3, 7 and 9, 15. So what we'll do is we'll use the distance formula. Distance equals the square root of. Let's work out the distance between the x values, which is 9 take away 3, which is 6. I'll just write 9 take away 3 all squared. plus 15 take away 7 all squared. D equals, now again, this is assuming that we're taking the positive root here. So this is going to be 36. 9 take away 3 is 6. 6 squared is 36. Plus 15 take away 7, that is 8. 8 squared is 64 square rooted. D equals. All right, so what we're going to do is add these together. So that's 70. That's the square root of 100. Distance is equal to 10. So the distance between these 2 points is 10 units. All right, pretty tricky problem, this one. So find the values of A if the distance between 2, A and 4, 9 is root 5. The best way to do this one is to simply write the distance formula out. So we'll go, we try that again. It's better. X2 take X1 all squared plus Y2 take Y1 all squared. All right, now we've been given the distance, so let's pop that in as root 5. Okay, so the distance here is going to, let's go 2 take away 4 or 4 take away 2. It doesn't really matter which way we do it. So we're going to do 4 take away 2 all squared plus 9 take away A or A take away 9. Either way, when we square the result, we'll either get, we'll square a negative or square a positive. It'll come out the same. But I'm going to do 9 take away A. Okay, so what we need to do here is we need to solve for A. Okay, so at this point in time, what I'm going to do is to get rid of this square root sign, I am going to square both sides. So I'll square this side and I'll square this side. And what that does is it undoes the square root. All right, this part here is 4 take away 2 all squared, which is 4 plus 9 take A all squared. All right, now let's subtract 4 from both sides, and I've got 1 equals 9 take A all squared. All right, interesting juncture in this problem. So what I need to do is solve for A. So what I'll do is root both sides. So what I'm left with when I root this side and I root this side is 9 take A equals, now I'm going to square root this side and square root this side. And because I'm doing this on an equation, that's a bit like solving this. X squared equals 9, x equals plus or minus 3 when I root both sides. So it's the same thing over here. What I'm going to do is root both sides and note that this is plus or minus 1 as an answer. Okay, so now we're saying that there's 2 possible answers here. So I'm going to say that 9 take A could be 1 or positive 1, in which case negative A, so I'm going to solve it using some algebra here, is equal to negative 8. A is equal to 8. So there's one possible solution. Okay, the other one is 9 take A equals negative 1. I'm going to subtract 9 from both sides, and that's 10 equals negative A. And what am I doing? Negative 10, A equals negative 10, A equals 10. All right, so they're my 2 possible solutions. Now, which one do I take? Do I take both? Do I take one? Well, here is the answer to our problem. So what I'm going to do is put this on GeoGebra and let's have a look at what our solutions actually say. Okay, so the first thing is I'm going to write down our point 4, 9. Where is it? There it is there. And I'm going to write down 2, A, right, where A will come up as a parameter, and we're saying it can be 2 values, 8 and 10. All right, so here is our slider, and we're going to set that to whichever values we want. Notice that that value or the A will change, all right? Now, I'm going to draw a line, interval between 2 points. So there is a line that shows the interval between 2 points. So notice there that that line there, it changes depending on the value of A. So to go forward with this, I need to just change the properties of this and increase the max value it can take on. Let's just go 12. And increase the size of my Cartesian plane so we can see what's going on. So this suggests that when A is equal to 8, try and get it exactly on, there we go. That's the distance there, okay? And the distance is root 5. I don't know whether I can get a distance. Distance. Probably should plan this out beforehand. I'm gonna say that we can't get a distance there. So I'm just gonna say that let's do it by side. So we got that. All right. So here's the other one, A equals 10. We're just going to go the other side of the point. There it is there. And what you might note, hopefully you do, is that the distance there when A is equal to 10 is the same as the distance when A is equal to 8. It's exactly the same thing, all right? I'm going to do it more formally and put in the two possible values, which is 2, 8 and 2, 10. These are the two possible solutions. And again, draw the line segment in for both. And hopefully that makes it really obvious that both of those line segments are exactly the same distance. So what we're going to suggest is the values of A at A equals 8 and A equals 10 both produce a distance of root 5. So they're both acceptable solutions. A equals 10 and A equals 8 are both going to be solutions to this problem. All right, so test yourself out against those questions there. Let me know if you have any problems.